Good morning, students. In the last lecture, we had studied about classification of organic compounds on the basis of functional group. So we had studied 23 different types of functional groups present in organic compounds. The next point from this chapter is to study isomerism. This is important concept given in organic chemistry. So what is isomerism? The definition of isomerism is the compounds having same molecular formula but different structural formulae are called isomers, and this phenomenon is known as isomerism. So what is isomerism? Organic compounds having same molecular formula but different structural formulae are called isomers, and this phenomenon is known as isomerism. In other words, this isomerism can be defined as the phenomenon of existence of two or more compounds possessing same molecular formula is known as isomerism. So this isomerism mainly is of two types. In organic compounds, the isomerism is of structural isomerism and stereoisomerism, two types of isomerism observed in organic compounds. So when two or more compounds have same molecular formula but different structural formulae, it is called as a structural isomerism. So first type of isomerism is this compounds having the same structural formula, different structural formula, and that is called as a structural isomerism. On the other hand, when different compounds have same structural formula but different relative arrangement of groups or atoms in a space, then that is called as a stereoisomerism. So stereoisomerism, that is having different spatial arrangement or arrangement of atoms in the group, is a different, that is called as a stereoisomerism. Then we will study these both types of isomerism in detail. So the first type is a structural isomerism. So we had already studied that what is structural isomerism. Structural isomerism meaning is when two or more compounds have same molecular formula and different structural formula. They are structural isomers, and this phenomenon is known as structural isomerism. That is, when two or different compounds having same molecular formula but different structural formulae, they are called isomers, and this phenomenon is known as structural isomerism. The structural isomerism is divided into four different types. One is chain isomerism, second is position isomerism, third is functional group isomerism, and fourth is metamerism or struct metamerism or tautomerism. So these are the four types of isomerism observed under the type structural isomerism. In the figure 14.9, The classification tree of isomers, it is given. We will just revise this first, and then I will explain all these types in detail. So first is isomerism, that is two or more compounds with same molecular formula. This isomerism is of two types. One is structural and other is the stereoisomerism. In the structural isomerism, two or more compounds with same molecular formula but different structural formulae. In the stereoisomerism, two or more compounds with the same structural formula but different spatial arrangement of groups, geometrical and other is optical type of isomerism. So in the first type, structural isomerism, the structural isomerism is divided into five different types, that is chain isomerism, have different carbon skeleton. Second is position isomerism. Here the different position of the same functional group on the same carbon skeleton. Then functional group isomerism, they have different functional groups but the same molecular formula. In metamerism, unequal distribution of carbon atoms on the either side of the functional group. And the fifth type is tautomerism, the rapidly interconverting structural isomerism. So this is a tree for the classification of isomerism. Now we will study all these types in detail. So the first is chain isomerism. When two or more compounds have same molecular formula but different parent chain or different carbon skeleton, that is referred as chain isomerism. This type of isomerism is also known as chain isomers. Here with the example, it will be very clear about the chain isomerism. So we will consider the first example as a butane. We know butane have structural formula CH3, CH2, CH2, CH3. This is N-butane or simply called as a butane because the straight chain of carbon atoms. The other isomer of butane, the chain isomer, because here three carbon atoms in a straight chain and one carbon atom is below or above this carbon chain. So CH3 group shown in the bracket, CH3 group that is shown in the bracket, it is above or the below this CH carbon, that is isobutane or called as a 2-methyl propane. Here there is a printing mistake in this formula. So correct this. So it is a CH3 CH. Below this CH there is a CH3. This 3 written outside the bracket, that is the wrong. So 3 must be inside the bracket. The CH group is not 3 times, but it is a CH3 group. So again I will repeat, CH3, CH, below CH3 and in front of CH group again there is a CH3. So it is 2-methyl propane or isobutane. These are chain isomers, have different carbon skeleton and the same molecular formula, that is C4H10. C4H10, that is a butane. Then the next type of isomer is position isomer. With the help of example, first we will study this isomerism. Here we can consider the 4 carbon containing carbon chain. So it is a straight chain containing one double bond between carbon number 2 and carbon number 3. If you give numbering to this carbon, CH3 is the first carbon, CH is the second carbon, second CH is the third carbon, and CH3 is the fourth carbon. So CH double bond CH, it is present between carbon number 2 and 3. So minimum number out of 2 and 3 is a 2, and hence the name but2-ene is given. Then next is here again it is a 4 carbon containing carbon chain, but the double bond is present between carbon number 1 and carbon number 2. So IUPAC name of this alkene is a but1-ene. So it is a but1-ene. It is the IUPAC name. Here the double bond is present, position is between carbon number 1 and 2. So minimum number between 1 and 2 is 1, and therefore the name but1-ene is given. Now we will study details about the position isomerism, the phenomenon in which different compounds have same functional group. Here the functional group is alkene, carbon carbon double bond, same carbon chain, this position but different position on the parent chain is known as position isomerism. Again, I will explain this position isomerism in simple words. So here the structural formula is the same, meaning it's straight chain carbon atoms in both isomers. Only the functional group position is at different carbon atom. Here the double bond is present between 2 and 3 and 1 and 2 carbon atom, that is the different position. So these position isomers have same molecular formula, same carbon skeleton, only the position of double bond is different. That is called as a position isomerism. Now we will study third type of isomerism given under structural isomerism is functional group isomerism. From the name functional group, it is very clear that this organic compound contains different types of functional group. Here we will study the example of functional group containing ether and functional group containing alcohol. So first we will discuss this about example. So the molecular formula given is C2H6O. So it contains 2 carbon, 6 hydrogen and 1 oxygen. So from this molecular formula, we can write two different compounds as dimethyl ether. It is CH3OCH3 containing 2 carbon, 6 hydrogen and 1 oxygen. Similarly, one more organic compound containing alcohol functional group can be written as CH3CH2OH is ethyl alcohol. Now these compounds have same molecular formula but different functional groups. These are called as a functional group isomers. Now, what is functional group isomerism? So the phenomenon in which the different compounds have same molecular formula and have different functional groups are called functional group isomers. Examples is dimethyl ether and ethyl alcohol. Both have same molecular formula, that is C2H6O. So next type, fourth type of isomerism is metamerism. So what is metamerism? Again, we will study first example given under this. Here we can consider the example as CH3CH2O CH2CH3 containing 4 carbon atoms total. Then hydrogen number is 10 and 1 oxygen. Here the functional group is ether in both isomers, but on the either side of functional group. In first compound, this two carbon atoms on left side and two carbon atoms on right side of the functional group. But in the second compound, this functional group left side contains only one carbon and three carbon present on the right side. I will read the formula. It is CH3, CH2O, CH2, CH3. This is ethoxyethane, and in other isomer CH3O, only one carbon is present to the left side, and right side is CH2, CH2, CH3, three carbon containing. So both these compounds have same molecular formula. Here the molecular formula is given C4H10O. They have same molecular formula, same functional group, but the carbon atoms present on either side of functional group are different. That is called as a functional group isomers. Sorry, these are called as a metamers. Again, I will explain now this what is metamerism. So the different compounds with same molecular formula, same functional group, but having unequal distribution of carbon atoms on the either side of the functional group are called metamers, and this phenomenon is known as metamerism. In short, the same molecular formula, same functional group, but on the either side of the functional group, there are different number of carbon atoms present, and this type of isomerism is called as a metamerism, and the isomers are called metamers. Example, we had already studied ethoxyethane contain functional group ether, left side 2 carbon, right side 2 carbon. But methoxypropane contains again ether functional group, left side of functional group 1 carbon, and right side of functional group there are 3 carbon atoms, and the molecular formula is same, that is called as a metamers, and this phenomenon is known as metamerism. Now, the fifth type of isomerism given under structural isomerism is tautomerism. Here, the same compounds exist as a mixture of two or more structurally distinct molecules which are rapid which are in rapid equilibrium with each other, and this type of phenomenon is called as a tautomerism. So such interconverting isomers are called tautomers. In nearly all the cases, it is the proton which shifts from one atom to another atom in the molecule to form its tautomer. We will study first example given under this, and it is here the carbon atom, that is functional group is CO, ketone, and adjacent carbon is alpha, which is bonded to hydrogen, that is alpha hydrogen. Now, its tautomer is this alpha hydrogen is shifted and bonded with next ketonic functional group, that is CO, and that is it becomes OH. It is in the form of alcohol, and double bond is shifted between carbonyl carbon and alpha carbon. So first form is called as a keto form, and other form is called as a enol form, and this type of tautomerism is called as a keto enol tautomerism, and that is about the tautomerism. Again, I will explain what is tautomerism. The same compounds which exist as a mixture of two or more structurally distinct molecules which are in rapid equilibrium with each other. This phenomenon is known as tautomerism. Now, the other type, this is a very common tautomerism, as a keto enol tautomerism found in carbonyl compounds. Here, a hydrogen atom shifts, alpha hydrogen atom shifts reversibly from alpha carbon to keto form to oxygen atom of enol, and this is called as a keto enol tautomerism, and that is about the isomerism in organic compounds. We had studied under this isomerism, that is structural and stereoisomerism, this geometrical and optical isomerism, that is given in the 12th standard syllabus. There we will study in detail again. And this geometrical isomerism that we will study in alkene chapter, that is in hydrocarbon. Then we had studied the structural isomerism, 5 types: chain isomerism, position isomerism, functional group isomerism, metamerism, and tautomerism. And that is about isomerism. Thank you.